Here we have a problem that we can prove by contradiction. The problem is, prove that the hypotenuse is always less than the sum of the legs. In this case, z, or the square root of x squared plus y squared when you use the Pythagorean theorem, is always less than x plus y. And we can prove this using contradiction. Let's suppose that the square root of x squared plus y squared, instead of being less, is actually greater than x plus y. So we're assuming that the opposite is true. We're assuming that the hypotenuse is actually always bigger than the sum of the legs. And of course, we're assuming that x and y are greater than 0. Real numbers greater than 0. So let's square both sides. We get x squared plus y squared is greater than x plus y squared. So that's x squared plus 2xy plus y squared. You can cancel a bunch of terms on the left and right hand side. And finally you end up with 0 is greater than 2xy. Now the problem is, this is stating that, and then let's just divide by 2. So they're saying that x times y is less than 0. And this is the contradiction, because in order for x times y to be less than 0, one of these terms has to be less than 0. Either x or either y has to be less than 0. And that's a contradiction from this term stating that x and y can only be greater than 0. Thus we have completed the proof, saying that the hypotenuse will always be smaller than the sum of the lengths, sum of the legs.